Once you have your design established in the 2-inch to 1-foot scale, you're going to need to calculate the surface area of the deck. We have everything that we need to know right here. We have the shape, it is drawn to scale, so we can easily figure out what the surface area will be. The first thing we want to do is calculate how many of these blue squares cover the surface of our deck design. To do that, all we have to do is split this complex shape up into smaller shapes and then calculate the area of each of the smaller shapes. Now, what jumps out at me right away is from here down, we have 1/2 of a circle. And of course, the area of a circle is pi times the radius squared. This is half a circle, so we're going to divide that whole thing by 2. Then it seems pretty obvious that we have a nice long rectangle here. And the area of a rectangle, of course, is the base times the height. We could do a few things with this area up here. What seems most obvious immediately to me is the fact that we have a triangle here and a triangle here, and that leaves us with another rectangle. Area of a triangle is 1/2 times base times height. And then here we have another rectangle where we will be computing base times height. These two triangles are exactly the same. They're congruent. So we could take this and multiply it by 2, and it would be the same thing as a square. This triangle stacked on top of this triangle would make a square. However you want to deal with that is up to you. Then once we've done that, we'll add that all together and we'll find out how many of these blue squares cover our deck design. Pi times the radius squared. The radius is half the diameter of a circle. So from there we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So pi, we're going to use 3.14 times the radius, 10 squared. And of course, this is half a circle, so we'll divide that by 2. Pi times 10 squared is 100, divided by 2. We can divide the 2 out, and then the 100 becomes 50, and we're left with 3.14 times 50. The base of this rectangle is 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 20. Okay? I count very fast, don't I? 20 times the height. 1, 2, 3, 4. That equals 80 squares. This rectangle is 1, 2, 3, 4, 5, 6, 7, 8. 8 times the height, 1, 2, 3, 4, 5, 6, times 6, and 8 times 6 was 48 when I went to school, which was just this morning. This this triangle, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So that'd be 6 times 6 times a half. 6 times 6 is 36. Divided by 2 is 18 squares. Now there's 2 of them, so this is also 18 squares. So we want to add up 18 plus 18 plus 48 plus 80 plus pi times 50. As I reach for my calculator, because that looks like an ugly calculation, 3.14 times 50 equals 157. So we want to add all of those together to find how many squares make up our deck. 150 plus 80, 157 I think it was, plus 80 plus 48 plus 18 plus 18 equals 321. Now, with 2 inches equaling 1 foot in this scale, one of those squares equals 2 2/4 square inches in real life. So we multiply 321 times 2.25, and our final answer is 722 1/4 square inches. Write that down on your design drawing. We're going to be using it later to calculate how much lift we're getting from our hovercraft deck.